How do embedded systems interface with other hardware components? In recent days, the world of technology has been buzzing with discussions about embedded systems and their role in modern devices. As we relying more on smart devices, understanding how these systems connect with hardware components is essential. Many people are searching for answers to the question, how do embedded systems interface with other hardware components? Embedded systems connect with other hardware components through various interfaces and protocols. These are designed to enable communication, control, and data exchange. This connection involves both hardware and software elements working together seamlessly. One key method of interfacing is through digital and analog input-output pins. Embedded systems often feature general-purpose input-output pins that can be configured as digital inputs or outputs. This allows them to read signals from sensors or control actuators. Analog inputs enable the system to read varying voltage levels from analog sensors using analog to digital converters. Another common method is serial communication protocols. These include universal asynchronous receiver transmitter, serial peripheral interface, and inter-integrated circuit. These protocols allow embedded controllers to communicate with peripherals such as memory devices, sensors, and displays by sending and receiving data in a defined format. For higher data throughput, some embedded systems utilize parallel interfaces. These interfaces allow multiple data lines to transmit bits simultaneously. This method is often used when interfacing with liquid crystal display screens or external memory. Embedded systems may also support standardized high-speed interfaces such as Universal Serial Bus, Ethernet, High-Definition Multimedia Interface, or audio ports. For example, embedded processors like advanced micro devices Ryzen with Embedded Plus architecture provide support for these connectivity options, enhancing device functionality. In more complex systems, embedded software engineers create device drivers to interface with custom hardware like field-programmable gate array devices. These drivers manage communication and control signals between the embedded system and specialized hardware components. Proper power supply design is also vital. It ensures that sensors and actuators receive the correct voltage and current. Signal conditioning circuits may be necessary to adapt sensor outputs to levels suitable for the embedded system's inputs. Firmware control plays a significant role as well. The firmware running on the embedded system manages how data is read from or sent to hardware components. It handles timing, protocols, error checking, and power management. Efficient firmware design is critical for reliable hardware interfacing. In summary, embedded systems interface with other hardware through a combination of physical connections, power management, and firmware control. This integration allows embedded devices to perform their intended functions within larger electronic systems. Understanding these connections is essential as technology continues to evolve and impact our daily lives.